In this video, we are going to learn how to solve for a variable in an equation. Before we can do this, we need to first identify what is a variable. A variable is a symbol we use to represent an unknown value. Like terms are terms with the same variables raised to the same power or exponent. Here we can see 6x and negative 2x are like terms. 8y squared and 10y squared are like terms. However, 6x and 8y squared are not like terms, or we can call them unlike terms, because they don't have the same variables raised to the same power. On the right side, we see that 1 and negative 8 are like terms. Numbers that are by themselves without being multiplied by any variable are called constants, and they are like terms with other constants. So in order to solve equations, or even just simplify expressions, one skill we have to master is how to combine like terms. We understand the idea of combining like terms when we're using constants, even if we don't think about it as combining like terms. It's like as if we had 7 plus 8, we wouldn't leave our answer like this, like we wouldn't turn this in as a final answer. We would simplify this, doing the operation out, and get 15, and this would be the final answer we'd use. So let's say I had this expression here. These are all like terms, right? Each of these terms have an x, and they're all raised to the first power. So I can combine all of this. I don't know what x stands for, so I'm just going to use a symbol to represent this value. So if I have 3x, that means I'm going to have 3 of these unknown values, which I'm representing with stars. Then I'm adding 2 more x's, so I'm going to add 2 more stars. And then it says I'm subtracting 4 x's, which means I have to erase 4 stars. 1, 2, 3, 4. So when I combine all the like terms, I'm left with just 1 x, which I don't need to write like this because the 1 is unnecessary, so instead I'm just going to write x. Here we can see we have 2 sets of like terms. We have these terms with these xy's, and we also have terms with x's. So I'm going to use different colors so we can identify which terms are like terms with each other and which ones are unlike terms. So using this 4xy, I'm going to represent the xy value with triangles. So I have 4 of them here. I don't actually know what xy stands for, so that's why I'm using these shapes. Then here I'm going to add 2 x's, which I'll represent with stars. Then I'm adding 1 more xy, and then adding 3 more x's. So now when I'm combining like terms, I can only combine the ones that match up together, that have the same variables raised to the same power. So here when I add 4xy and xy, I have a total of 5 triangles. So I end up with 5xy. When I'm adding 2x plus 3x, I have a total of 5 stars here. So I have 5x. I now have this simplified expression here where I've combined all like terms. 5x tells us that we're going to have 5 of these unknown values, which I'm representing with stars. 5x can be combined with this negative 2x, right? These are like terms. And the negative 2x tells me I'm going to take away 2 of these. So when we combine the like terms with x's, we end up with just 3x. This here is a constant because it doesn't have any variables, so I'm going to represent it with tally marks. So we have 1, 2, 3, 4. If we're adding 1, we're going to add 1 more to that. So when I combine the like terms with constants, I know I'll end up just with 5. This term here doesn't have a like term within this expression, but it is different from the other one, so we know that it is an unlike term. I'm going to represent this with a square. So in our final answer, when we're rewriting this, we're going to just end up with this simplified expression.